Now here we're gonna talk about the pH of a weak acid. So how do we calculate pH of a weak acid? So whenever we know that whenever we have a weak acid, so there must be some alpha degree of dissociation, and there must be Ka that we have seen earlier, and there must be Ka, and concentration should also be given. That K and C should be given and alpha should be unknown. We do not know what is the alpha. Okay, so here we're gonna calculate pH equals to negative log of H positive, and concentration of H comes plus turned out to be C alpha. So what I mean to say, let's go through an example. HA, we have an acid which releases H plus and A minus through a reversible reaction because it is a weak electrolyte, eventually a weak acid. So let's T equals to 0, the initial concentration is C. When the equilibrium is established, it C into C alpha, it turns out to be C alpha and C alpha. So Ka equals to H plus into A minus divided by HA. So H plus into A minus divided by HA, the Ka we have already learned how do we write the Ka. Now we'll put the value of Ka, H plus C alpha into C alpha upon C into 1 minus alpha. So it comes out to be C alpha square upon 1 minus alpha. So here we know Ka, we know C, now we can calculate alpha. Now do we need to always solve that quadratic equation in order to calculate alpha, and then we use that C alpha to calculate the concentration of H plus? Let's say we know that let's understand some basic mode of the approximation. You can say in chemistry, when we have 100 plus 5, I'm not talking about a mathematical term, but in chemistry, when we are adding 100 into 5, we can approximately say it is 100. Like if we are adding 100 and subtracting minus 5, we can say 95. So we can actually ignore 100 plus minus 5 to 100. So what does it mean? We can 5% change, we can accept it. If it is changing by 5%, we can say, let's say it is fine. It can be neglected while adding or subtracting, not by multiplying or dividing. What do I mean to say in order to explain that? So let's say if alpha, whenever it is dissociating, alpha is less than 5%. So we can neglect 1 minus alpha as 1. We can neglect alpha with respect to 1. So in order to make this equation simple, let's say we just 1 minus alpha, we neglected that. So that becomes K. So alpha becomes Ka by C, alpha square becomes, so alpha becomes under root over Ka by C. Alpha becomes under root of Ka by C. Now we have neglected alpha with respect to 1. That means we know that that should be less than 5%. That means 5 by 100. That should be less than 5 by 100. Now on moving further, if it is less than 5 by 100, Ka upon C should be less than 25 into 10 to the power minus 4. 25 by 1000. 25 by 10,000, that means 25 into 10 to the power minus 4. So first of all, in any problem, any you have given Ka, any you have given C. So first of all, you will divide Ka by C and check whether it is less than 25 into 10 to the power minus 4. Then you may go the method I am telling. Otherwise, you have to solve the quadratic equation in order to calculate alpha, and then H plus C alpha, then calculate the pH. Right. So then concentration, when let's say case 1, when alpha is less than 5%. So concentration of H plus comes out to be C alpha, and C is alpha is under root K upon C. So it is under root Ka into C. That is concentration of H plus. Then pH. The concentration of H plus we know, now we can easily calculate the pH. And concentration of OH minus can also be given by Kw divided by H plus. Kw is right 10 to the power minus 14 divided by concentration of H plus, whatever it is coming. Now let's say if not equal, not less than, Ka by C is greater than 25 into 10 to the power minus 4. Now you may be asking when it equals to. Whenever it equals to, you can choose the method of approximation, right? Because I have taken the 5. Okay, you just choose the method of approximation. You can neglect the alpha with respect to 1. But when alpha is 25 into 10 to the power minus 4, so what you can do? You can make K equals to C alpha square upon 1 minus alpha. Now you can not neglect the alpha. Now you have to calculate the alpha. Calculate alpha by solving the quadratic equation. Now concentration H plus comes out to be C alpha. C, you know alpha. Then you may solve this problem like that. Now let's do some practice. How do we calculate the H plus and all the things? Now there gonna be a lot of practice regarding these questions. So let's write the question number 1. You have an acetic acid. When acetic acid is a weak acid, K must be given 10 to the power minus 5. Now you can calculate alpha, concentration of H plus, OH minus and pH. For first of all, you are given 0.1 molar solution, and the second one you have given 0.01 molar solution. So if I try to solve that, first Ka first, now it is the H plus we know that will be C alpha. Now alpha do we need to calculate by the quadratic equation, or alpha do we need to calculate by under root Ka upon C? So first let's come to what is Ka upon C. So K is 10 to the power minus 5 upon C is 0.1. So it is coming out to be 10 to the power minus 4. So it is less than 25 into 10 to the power minus 4. So we can neglect alpha 1, then the concentration. Now alpha comes out to be under root of Ka by C. That is 10 to the power minus 2, 0.01. We now, with respect to 1, we can neglect 0.01. So concentration of H plus comes out to be C alpha. And C is 0.1 and alpha is 10 to the power minus 2. The concentration of H plus comes out to be 10 to the power minus 2. So pH equals to 3 and POH equals to 11. So that was all about the first problem. Now if we have 0.01 molar of acetic acid, so Ka by C comes out to be 10 to the power minus 5 divided by 0.01, and that comes out to be a 10 into 10 to the power minus 4. Now 10 into 10 to the power minus 4, yes, it is also less than 25 into 10 to the power minus 1. We can neglect it. Alpha with respect to alpha eventually comes out to be C alpha. Alpha comes out to be Ka upon C. Under root of Ka upon C. Under root of this term. Okay, so it is 10 into 10 to the power minus 4. So it is 3.16 into 10 to the power minus 2. We can simply see that it is 3.16% dissociated. If we see the previous problem, it was also 1% dissociated. Out of 1 mole of only 100 mole, only 1 mole will dissociate into constituent ions. And now the concentration of H plus comes out to be C alpha. So it comes out to be 3.16 into 10 to the power minus 4. Right. So pH comes out to be 4 minus log 3.16. So it is comes out to be 3.5. So concentration of OH minus comes out to be 10 to the power minus 14 divided by 3.16 into 10 to the power minus 4. So that was a very basic question. You can see now what we are observing when we are increasing the volume, when we are in dilution, the concentration is decreasing. Or when the alpha is increasing, alpha has been increased. When we increase the volume, dilution concentration will increase, and alpha will also be increased. Now concentration of H plus is decreased, concentration of OH minus is increased, and pH will also increase. So on increasing the dilution, the pH is increasing, right? So Ostwald dilution law told the variation of alpha with dilution. So initially it was 1%, now it has been gone to 3.1%, but it didn't commented about the pH. So obviously we know that when we are diluting the any strong acid, it will eventually become the weak acid. So it is becoming the weak acid, but alpha will increase, right? Now let's jump to our second problem. Again, I'll encourage you to first read the problem, pause the video and try by your own. 0.01 molar of CHCl2COOH. Ka equals to 1.25 into 10 to the power minus 2. You can calculate alpha, H plus, OH minus, and CHCl2 COO negative concentration. So first of all, again think, we have learned a lot. Easily you can trigger out the solution. So what now let's start. We know first of all, in case of weak acid, we need to calculate Ka upon C. So what is Ka upon C? Ka is 1.25 into 10 to the power minus 2 divided by 10 to the power minus 2 in the C. So it equals to K by C is coming out to be 5 by 4, which is 1.25, which is obviously greater than 25 into 10 to the power minus 4. Now what? Now it is greater than, now we cannot calculate neglect alpha with respect to 1. That we know that CHCl2COOH is dissolving like Cl2COO negative then H positive. So it is C into C 1 minus alpha, C alpha, C alpha. K is 1.25 into 10 to the power minus 2. That is C alpha into C alpha divided by C into 1 minus alpha. I am not going the exact derivation that I have done. You may see the previous initial time of this video. You can easily learn how we are coming into that. So if you cancel all the C, that it comes out to be C alpha square divided by 1 minus alpha. Now C alpha square divided by 1 minus alpha, and that is coming out to be Ka upon this C. We know C is what? C is 10 to the power minus 2 into alpha square upon 1 minus alpha, and both are cancelled. 5 by 4, that is alpha squared upon 1 minus alpha. So alpha, if we write the quadratic equation, it is a figure coming out to be 4 alpha squared plus 5 alpha minus 5 equals to 0. Then alpha equals to negative of 5 plus minus under root b square. B square is 25 minus 4ac is 80 upon 2a is 68. So it is coming out to be 5.2 upon 8. That is 0.65. So alpha is 65%. So obviously what we predicted was correct. It is not approximate, not less than 5% or equal to 5%. It is very greater than 5%. It is 65%. So the concentration of H plus, equals to CHCl2COO negative to 0.65 into 10 to the power minus 2. That is coming out to be 6.5 into 10 to the power minus 3. So concentration of OH minus coming out to be 10 to the power minus 14 divided by 6.5 into 10 to the power minus 3. So now you can have also seen that one example where we have not neglected the alpha, and with the basic we can calculate the concentration of H plus in, that is C alpha. So C is 10 to the power minus 2, alpha is 0.65. So and that is Kw upon H plus. Now there are a lot of good questions come out too. There are some tricky questions where you might stuck. Let's also go through that. Now let's say you have given concentration. Concentration is 10 to the power minus 3 molar, and alpha is 0.1. Ka and pH we have to calculate. So concentration of H plus equals to C alpha, that is 10 to the power minus 4 molar, and pH comes out to be 4 molar. Right, we have calculated the pH. Now we need to calculate the Ka. We easily calculated the pH, and we need to calculate the Ka. The pH simple C alpha. When alpha is it is less than 0. Alpha is 0.1 is given. So alpha we no need to compare or calculate, it is already given. So H plus is C alpha. Now how do we calculate K? C alpha square upon 1 minus alpha. Now we know the C, we know the alpha. Okay. So just put the value. 10 to the power minus 4 into 0.1 upon 1 minus 0.1. So that is 10 upon 9 into 10 to the power minus 5. That is 1.1 into 10 to the power minus 5. But there must be a twist in the problem. What should be the twist in the problem? Let's jump into another problem, and I'll totally encourage you to brainstorm yourself. Just think about the problem. What could be the easiest way to solve the question this time? K is 25 into 10 to the power minus 5, and concentration of H plus is 4 into 10 to the power minus 5. So now you need to calculate the concentration. Calculate the, you have given Ka and concentration of H plus. How you will be calculating the concentration? Now if you go to the traditional method, Ka equals to C alpha square upon 1 minus alpha. You don't know C, you know under root C alpha, and there is one like if you think like a basic under root C alpha, and you will calculate pH. Okay, put the value of then you have don't know C, you don't know alpha, so you will be a little bit messed out. So what to do? We know, let's segregate C alpha into alpha upon 1 minus alpha. So that C alpha is what? Concentration of H plus. So put the value of H plus. 4 into 10 to the power minus 5 into alpha upon 1 minus alpha. Right? And we know the K 25 into 10 to the power minus 5. Now by solving this, we cancel 10 to the power minus 5 to 5. 4 alpha equals 25 minus 25 alpha. Actually it is 2.5. Just change this. It is 2.5. Okay, right. Now fine. It is 25 into 10 to the power minus 5. And that is 4 into 10 to the power minus 5. So 10 to the power minus 5 to 5 cancel. So 4 alpha equals to 25 minus 25 alpha. So alpha is coming out to be. So alpha term comes out to be 25 upon 29. So concentration of H plus can be calculated by C alpha. C is now we know the H plus, but here we need to calculate the alpha. Now we can calculate. Now we have calculated the alpha. Now concentration of H plus is again C alpha. 4 into 10 to the power minus 5 equals to C into alpha is 25 by 29. So here you can calculate the value of C. So somehow we have given the concentration of H plus, so we have to segregate it like this.